Alice discovers the first proof of hyperhelium-4's antimatter companion. The conditions that existed immediately after the Big Bang reappear for a fraction of a second in collisions at the CERN Large Hadron Collider. Because they aid in the exploration of the boundaries of our physics, physicists are eager to identify the most unusual particles among the plethora of particles that form during those moments. Now, scientists working on the Large Hadron Collider experiment, Alice recently revealed an extremely strange one. Lead collision data collected in 2018 at an energy of 5.02 teraelectronvolts per colliding pair of nucleons served as the basis for the Alice measurement. The Alice researchers examined the data for signs of hyperhydrogen-4, hyperhelium-4, and their antimatter partners using a machine learning method that performs better than traditional hypernuclear search methods. By searching for the anti-helium-4 nucleus and the charged pion into which it decays, candidates for anti-hyperhydrogen-4 were found. On the other hand, candidates for anti-hyperhelium-4 were found by its decay into a charged pion, an antiproton, and an anti-helium-3 nucleus. The quantities of these particles created in lead collisions were also ascertained by the scientists. They discovered that these figures aligned with the Alice data, which shows that quark-gluon plasma generated at the energy levels the LHC can reach produces equal amounts of matter and antimatter. However, anti-hyperhelium-4 and anti-hyperhydrogen-4 may offer crucial hints to the cause of the universe's matter-antimatter imbalance. The paper has been submitted to physical review letters and is available before peer review on the Alice site for physics publications and article submissions.